So now, some of the possible solutions for building a sustainable energy system. The solution space is huge. And we're only going to highlight a very few things here, but I'm picking out some of those that are especially likely to help. Start here. Everything in color on these maps we use to get the 2,000 calories per person per day that are the human diet. On top is croplands, on the bottom is grazing lands where animals eat grass and we eat the animals or we milk them. Suppose we decided to replace every bit of external energy used by every human from oil and coal and gas and nuclear and everything else with a modern solar farm, and then we added a little extra to allow growth. That pink square in the Sahara would be enough to replace all external human energy use. Now, we're not going to put it all there. Some of it's on the roof over my head right now, but that gives you the scale. It's a huge area. It's a huge task. But it's surely doable. And that's the really important thing. And it's small compared to what we've already done to the land. When we made the PBS miniseries, Earth the Operator's Manual, we got to go talk to some Texas ranchers. They were having real economic trouble. There was danger of the town going broke, the high school being closed, people losing the ranch. They put in a wind farm. And they get what they call mailbox money. You go out to the mailbox and it's full of money. 5% of the land in renewable energy often pays more than 95% of the land in the old ranching. If we put a wind farm on the windy parts of the plains and deserts of the world, the places where the wind blows enough to run the turbines at least 20% of the time, that would be 5 times more energy than now used by all humans. So the resource is there. The International Energy Agency they spent a lot of years sort of not being enthusiastic about renewable energy. But by 2020, they got to the point of saying, hey, it's the cheapest electricity in human history. Cheaper than anything else in many places. Okay? So the cheapest electricity in human history with a resource that's far greater than what we can use at this point. But there are ways to combine this wisely. This particular experiment was done at Oregon State. It dries out there in the summer, and when they put solar cells in, it held some snow underneath early in the year. It kept it a little moisture farther into the summer. They got extra hay cutting because they were also getting extra electricity from the solar cells. This was an experiment done in Germany. They made high solar cells that you could drive tractors under. They planted different crops extending outside and under so they could compare how it worked. And this summer had a nasty drought. And in this summer, they got more food where they were also getting electricity. So you're getting more money from the electricity, but they also got more food because of reduced evaporation in the drought. So there are ways to combine these things. Right? There are just times when it's nice to have a little shade. And because the area needed to do this is so small compared to the area we use for agriculture, you could design things that give us the best of both worlds. This particular study said, global energy demand would be offset by solar production if less than 1% of cropland is converted to this dual use. We grow food and we eat it. We grow food and we feed it to animals and we eat them or we milk them or take their eggs. We grow food and we burn it. Some of it is ethanol in gas tanks, and we burn palm oil and other things, biodiesel. We use more than 1% of the cropland now for food that goes into biofuels that we burn. We could get all of our energy from that much area. So somebody says, oh, we don't have the land to do this. They're not really serious. You go places that we irrigate, water is evaporating from the irrigation canals, and that's food that we're not growing. If you put solar over the top of the irrigation canals, less evaporation, more water, more food, and you're getting energy from those solar cells. It's a win-win-win. This is for the U.S. grid. This comes from Lazard, the world's largest independent investment bank. They've said, suppose there were no subsidies for wind and sun. How much does electricity cost if you want to add a little to the U.S. grid compared to other sources? And here's a blow-up of this. Cheap is over on your left, expensive is over on your right, going that way. And what you'll notice here is that the renewables are the cheapest now. Gas generally costs more, coal costs a lot more, nuclear is having real troubles being competitive. Gas peaking is just you run it when you really need it. These two diamonds down here are if you have an old nuclear plant or an old coal plant, it's completely paid for, it is wired in, all the construction is done, and you're not paying it off. And that's just to operate it compared to building and operating new renewables. This is why you're seeing coal and nuclear in looking for subsidies from state governments and elsewhere, because they're having real trouble competing with the renewables at this point. Now, this would look much better for the renewables if fossil fuels were not subsidized, because we now have authoritative statements that the fossil fuels are much more subsidized than the renewables are. So this is something from people working with the International Monetary Fund. The IMF has been updating this, and they found that now the subsidy for fossil fuels in the world is more than $7 trillion a year, or more than 7% of the world economy. More or less, when we pay $1 for fossil fuels, society pays another $1. Some of this is direct subsidy, tax breaks and other things. Mostly it's because when we burn fossil fuel, the cost of the health impacts, the cost of the changing climate is paid by society, not by the consumers of the fossil fuel. And the IMF folks found that if we eliminate this subsidy, we would cut air pollution deaths, we would reduce CO2 emissions more than half, we would increase the well-being of people. Now, do not kid anyone. Building a sustainable future is going to be hard. It is going to be decades. We don't really have all of the answers, but we now know that it can be done. And if you're a young person, you're part of the first generation in history that knows that you can build a sustainable energy system, and that doing so can help the economy and health and security, employment, environment, ethics. I took this picture in Greenland. Can we really have a world with icebergs and rainbows? Yes, we can. And I think that is really good news.